We hope you are doing marvelously well. You may have noticed over the last year, something has changed when it comes to cloud misconfiguration exploits. They become far more sophisticated in how they leverage a series of misconfigurations to gain initial access to cloud environments, discover resources to target, move laterally, and extract data, all typically without any kind of detection at all. Many of these misconfigurations are not flagged by compliance frameworks or security teams. And the reality is, at scale, cloud infrastructure environments are just too vast, complex, and dynamic to secure with traditional tools and manual reviews. We think what's needed is security automation using open source policy as code. So you should see a poll question pop up on your screen. We would love to know if your team has adopted policy as code specifically for cloud infrastructure. We're excited to have Dave Williams, cloud architect at New Light Technologies, and Carl Aline, senior DevSecOps engineer at New Light, to join us and help us walk through how we can use Open Policy Agent for cloud infrastructure and take a look at some other useful tools in the OPA ecosystem. And here to introduce these concepts, we have Fugue's co-founder and CTO, Josh Stella. I will be back later to facilitate your questions, so please do get your questions in early and often. And with that, I'm going to hand it off to you. Take it away, Josh.
Thank you, Drew. And super excited that we've got Dave and Carl with us. They're going to do the fun and cool stuff today. I'm going to walk you through some slides, but they're going to do some live demonstration, some live fire demonstration of how this stuff works. But just to get things started, we want to do a little bit of introductory information around misconfiguration, OPA, et cetera. So the agenda today, we're going to do an overview of what cloud misconfiguration is and the risk of it. We're going to talk about some cloud automation topics, from infrastructure as code to policy as code. We're really talking mostly about layering in open source policy as code into your software development lifecycle on the cloud today. We'll go into a little bit on Open Policy Agent for policy as code, which we think is a really important new standard for doing policy as code. In the past, it's been fairly proprietary, so we're excited about this. And then Dave and Carl are going to take over and do some technical deep dives into how they've implemented this, and we'll wrap up with a little bit of some pointers to how to get started and some Q&A. So please fire your questions in all the way through. We'll collect them up and talk to them at the end. Okay, let's talk about cloud misconfiguration. Cloud misconfiguration is the big security risk on the cloud. And as Neil McDonald of Gartner said here, nearly all successful attacks on cloud are the result of customer misconfiguration, mismanagement, and mistakes. And that sounds pretty accusatory. One, it's accurate. You do not typically see, I'm not aware of any instances of the cloud vendors themselves having technical issues that allowed hackers in through control backplanes or anything like that. It's almost always, in fact, probably always, misconfiguration of cloud resources. Things like leaving IAM roles with too much permissions for listing S3 buckets, stuff like that. So over on the right here, you see 93%, about 93% of what? Last year, Fugue did a big survey of folks who are operating at scale on cloud. We had over 300 organizations respond to this survey, and that's where the statistic comes from, and some others that I'm going to show you. 93% of them were concerned for a major security breach due to misconfiguration. Those 93% are correct and should be, and the 7% that aren't are probably going to get breached, would be my guess. This is something you constantly have to worry about. The attack vectors are numerous, complex, and difficult to predict. The bad guys are super clever, and they leverage lots of different service types to steal data, do crypto mining, et cetera, in your cloud environment. So from the same survey, we asked people what they were most concerned about in terms of cloud misconfiguration. And 2/3 said identity and access management, IAM. I was very pleased that came in first, because it is probably one of the scariest parts of cloud configuration, one of the easiest to get wrong, one of the most difficult to understand your actual security posture because of the kind of network-like nature of IAM. So I was pleased it came in first, but again, that should be 100%. Coming in second, because everybody needs to be constantly worried about how these identity and access management roles and policies interact in complex graphs over their infrastructure. Second, security group rules, essentially firewall ports. We see this all the time at Fugue. Somebody opens a port for maintenance, forgets to close it, and there's exposure. I mean, there have been a number of breaches recently where people left things like Elasticsearch, ports open and never turned on authentication and authorization, and entire data sets that were cached in Elasticsearch, appear on the dark web the next day. Third, so that's a good one to be worried about. Third, object storage access policies just at north of half. I find this interesting because if you were to read the news and think that the journalists always got it right, this would be in first place, right? Because you're always hearing about like object storage data leaks. And yes, you definitely need to be really good at managing these. But usually in real world breaches, it is a combination of IAM security groups and then object storage access policies that allow someone to get to those object stores. So if you have the right IAM permissions, you can steal all the data in just a few minutes. And then finally, encryption in transit disabled. So I was really encouraged to see this from those survey respondents, because I think it's an accurate, by my view anyway, and Fugue's view, assessment of where the risks lie. So cloud misconfiguration is often overlooked. It's really, really tricky. And the reason is the cloud is very different in architecture than the data center. Things like TCP/IP networking and having boundaries on your networks and so on, you still do that stuff, but it's not usually actually how the bad guys are exploiting these resources. So most of these cloud misconfigurations are not even recognized as misconfigurations by security teams, because in this new cloud world, the attack surfaces are different, and they're not just different in size and shape, they're different in kind. The compliance frameworks are really far behind on this in terms of they're still thinking mostly in data center terms, and it takes months for additions to get through, like NIST and CIS, et cetera. So they're not necessarily going to warn you, if you're relying on them to tell you where you have misconfiguration. They're not necessarily going to warn you about the misconfigurations that the bad guys are actually exploiting. And therefore, what that leads up to is that therefore misconfigurations are exceedingly common in enterprise cloud environments because they're not recognized as misconfigurations and they're not considered policy violations by compliance frameworks. Adding complexity to this is that the cloud is in constant motion, right? You can summon a VPC network with a single API call. In the data center days, to build a complex network would be a multi-month, multi-million-dollar, lots of change control boards in place. So these things are just coming and going rapidly in the cloud. So it really is like needles continuously appearing and sometimes disappearing in a haystack. It's a non-trivial problem. Adding to this, hacker strategy has really evolved. So here it says before cloud and cloud. It's really kind of historical and modern. So historical, I mean, you kind of think about the classic story of a breach. You imagine, bad guys sitting there saying, we're going to go after Sony. And actually, I use that as an example because that is what happened to Sony. The North Koreans went after Sony in particular, identify the target organization, and then search for vulnerabilities to exploit or do spear phishing attacks, et cetera. That still happens. It's not like we can relax about those kinds of exploits. but far more common now are these automated misconfiguration exploits. So what's happening in the cloud era is the bad guys are using automation to go find anything you've misconfigured. And then they get back a nice shopping list of organizations that they would like to go target. So what this means is a friend of mine who does a lot of research into breaches told me that in his estimation, the average amount of time, or by his calculation, I suppose, the average amount of time that it takes for a new IP address / DNS record for a piece of infrastructure to appear on the public internet and for bad guys to have scanned it for misconfigurations and vulnerabilities is approximately 7 minutes. So that's how long you have. So the bad actors are using automation to find and exploit cloud misconfiguration. What that means is it doesn't matter whether you're a giant organization or a little tiny one, they're looking at you all the time because they're using automation to do it. There is no longer any value to security by obscurity. It was never a good idea. It's dead and buried now. So let's go through just briefly an example of an advanced misconfiguration attack. I won't name names, but this is an analysis of a big one that happened last year. The first thing, there was a firewall misconfiguration, a bad port left open. Very often these are due to like 1 a.m. maintenance window kind of scenarios where somebody opens a port to do some maintenance and then forgets to close it at 3 a.m. And it sits there and somebody finds it through that automation. In this particular case, there was also a forgotten about EC2 instance. Therefore, it was stale in terms of patches, had known CVEs, and got exploited. And then that was used as a kind of landing zone to do a couple of things. One, though, that EC2 instance didn't have particularly useful permissions via IAM, so the attacker had to do what's called an IAM role assumption, which is changing the IAM permissions. Remember, I said it's like a network. It's like a network. You can change those permissions, the role for IAM, and you can get access to stuff. And in this case, some of that was the ability to go discover all those S3 buckets and to duplicate all the contents in a very kind of fast and devastating way. So this shows that it is the combination of these misconfigurations that really expose you. And these are very small, items in what are probably very, very large environments. So why is this happening now? I mean, people say, oh, is the cloud less safe than the data center? No, it's not. The cloud is actually potentially safer than the data center, but you need to use automation. You need to use policy as code for various reasons. In the data center, it was physical infrastructure, pretty static, manually deployed, configured, and maintained. What that meant was there was a lot of friction in the process of putting it in place and configuring it. By friction, I mean things like picking a vendor, writing a PO, having it show up on the loading dock, having usually something like an Excel spreadsheet telling the guys who were racking and stacking it where to put it and what to plug into what. Its configuration. This was a weeks or months long process, sometimes more. And what that gave us was the ability to tell ourselves, because it was rarely true, but to tell ourselves that we were configuring things properly and that they were secure, etc. In the cloud era, building that whole network, again, is a single API call or a handful of API calls. These environments are highly dynamic. So these things are appearing and disappearing at incredibly rapid speed. All of the friction is now gone because it's API driven. And that means that securing things manually is basically impossible. And the bad guys are attacking things automatically, right? So we have to automate our security and our policy in cloud to keep up with the pace of cloud. But the good news, the silver lining to all this is, for the first time ever, those same APIs that can be used to deploy and configure cloud infrastructure at speed, those same APIs give us the transparency to secure them at the same speed if we do it right. So a common approach to this is to use infrastructure as code, which leverages the programmability of cloud infrastructure. It's repeatable, it's testable, it's shareable, scalable, and peer-reviewed, Terraform, CloudFormation, things like that. But we need to match that with policy as code for security at scale. So in the data center, the infrastructure teams would develop the infrastructure to the app teams would deploy into that infrastructure, and validations and audits generally performed manually, as I just described. In the cloud era, the developers create and modify their own infrastructure. When you build an app now, the app gets infrastructure as a side effect, as part of its process rather than you having a data center of stuff and you deploy an app into something that's been secured. You're creating that stuff for the app. And therefore, you really need to go from a manual process of validation, and audits are just painful for everyone. We want a better way than manual validation and auditing. What we want to do is automate with policy as code so that the machines can do this for us instead of us doing it in painful and imperfect ways. So that policy as code is going to empower the engineers who are now in control of the infrastructure to also own the security of their cloud infrastructure by getting real, useful, actionable feedback, particularly when they're doing something dangerous. So you can do this all the way across the SDLC. You should do this all the way across the SDLC. If you don't, you're either going to be spending money or being less secure in ways that you don't want to. So the design phase, and that's really what we're going to focus on today, you can validate infrastructure as code, like Terraform, with policy as code to correct the violations early. And that's what New Light are going to do this really cool demo of, and I'm going to talk to as well. But then you also want to maintain that policy as code throughout the deployment process into production so that you can enforce it. So you want to check up front. We're going to focus on that today by looking at your infrastructure as code, but then you want to bake into your CI/CD pipeline the ability to prevent bad deployments. When policy as code says this is dangerous, you should not build that and put it in production. And then once it's in production, remember the use case, the scenario I was talking about before, somebody goes in to do a maintenance window and leaves a bad port open. In that scenario, the checking it at design time doesn't help you, right? Because you got it right at design time, somebody messed it up later. And so that's where you need that same policy as code to go all the way through the SDLC. And that brings us to the coolness that is Open Policy Agent. So it's an open source project. It is part of the Cloud Native Computing Foundation, the folks who manage Kubernetes. It's applicable to a variety of use cases. We're going to show you one today that is pretty new. And it's really popular, and there's a growing ecosystem of tools that we're contributing a lot to here at Fugue. So we're going to show you Regula today for validating Terraform. I'm going to pull up GitHub here in a second and show you where all these repos are. New Light has put out this really cool thing called the Automated Infrastructure Compliance Framework, also on GitHub, and they'll show you where that is. And then Fugue also built a thing called Rego, which helps you work with the OPA policy language, Rego. The beauty of this is it's not proprietary, it's open source, and it's now becoming a standard. And that means you can have policy as code that's portable between tools and use cases, and your developers and engineers will get their careers enhanced by learning OPA and Rego. And that's critically important to really, operationalizing and really doing this stuff in your organization. Okay, I'm going to take just a second here, and I'm going to jump out of slides, and I'm going to show you some websites just to familiarize you with these things. So let's talk a little bit about Open Policy Agent. This is the GitHub repo for OPA. We'll have the links available. Again, it's Cloud Native Computing Foundation. This is not Fugue's product or project. Styra are the folks who maintain it. We work closely with them and contribute to it. but it's really cool stuff. You can see how does OPA work. You essentially define rules that tell you whether or not your infrastructure or your configuration is going to meet policy, and we're gonna drill into some of that in just a little bit here. A little more about OPA. Where was it? Yeah, if you look at the adopters page, you'll see there's a pretty interesting group of folks here. So Chef is using it for IAM style access control. That's a really common use case for OPA. Cloudflare for validating admission controllers. We're doing a bunch with it, which we'll show you. Intuit, Netflix, Plex, SAP. You know, it's really taking off. Cisco, others. So, so that's OPA. It's Open Policy Agent. They call it OPA as opposed to OPA. Fugue has put out a couple of things for it. One, and we're going to focus mostly on this today, is called Regula. So what's Regula about? It's about using OPA to check Terraform infrastructure as code templates for correctness as compared to policy prior to deployment to the cloud. So Regula is a handy tool that uses OPA behind the scenes to do all of that checking, and can give useful error information into the actual build process in a CI/CD pipeline, so that you can do things like fail builds prior to deployment, which is what you're probably going to want to do. You might just want warnings in dev so that your developers can learn exactly, you know, what the problem is and how to fix it. And by the way, you don't even have to install it. You can just use a GitHub action, which if you haven't used are pretty cool. We have a GitHub action up here for Regula to start testing your Terraform. Also, we have this really nicely done blog post by our very own Becky Lee here on the Fugue website that really walks you through a successful use of Regula. So let us know what you think. Finally, I want to show you Rego, which is the Fugue Rego toolkit right here. This is a set of developer tools. So if you're learning Open Policy Agent and you want things like really handy error messages and the ability to set breakpoints and, you know, have a better development experience with OPA and with its language Rego, this is out here on GitHub. You can run it on whatever you want. It's got a REPL. It's got all kinds of cool features, and it's just free and open source on GitHub. I'm going to switch briefly now to a code editor and just show you a little chunk of Regula. So down the side here, we've got, you know, I've just downloaded the GitHub repo from GitHub. And you can see we've got a section called rules. This is where the interesting stuff lives. And in AWS, we've got a number of rules here, and we're adding to these all the time. Regula is a fairly new project for us. It's only been around for a few weeks. We've got about a dozen rules in AWS. We just added some GCP rules for Google. And you'll see a couple things in here. One is we're going to tell you up here why this rule matters. Okay, like if you're a developer and you have 3389 open, that shouldn't be open according to CIS. We're also doing mappings back to CIS with these rules. So you just get this stuff for free with Regula, which is free and open source. So here, just a little bit about how OPA works. What we've got here is a default deny is false, and then deny any of these things that would have port 33.9 open, any kind of ingress ports, right? So here we're just saying block that. Pretty simple one. You can do some pretty sophisticated stuff with Rego. Where's the fancy one here? This is don't let this scare you. If you're an engineer, a software developer, you might see this is like less than 50 lines of code, and it's doing some pretty sophisticated things here against multiple resource types in your infrastructure. Here we're saying IAM policies should not be attached directly to users, right? And so here is just this very simple code blocks. It's all declarative. It's effectively a query language, and it's open source. And if you learn it, you'll be in really good company with folks like the engineers at Netflix and Pinterest and lots of others. So I think there, I'm going to hand it off to our good friends at New Light, to walk us through some real live use cases with this. Dave, Carl, I'll turn it over to you.
Yeah, thanks, Josh. Carl, can you hear me?
Yes, I can. How you doing?
Great, pretty good. Thanks for having us.
Loud and clear.
Yeah, we're really excited to be here, and glad everyone could attend. So, go ahead and Carl, I think you're going to share for this. All right, let's go ahead and pull up the Terraform script that we're going to show. So what we're gonna go through today is a demonstration of a pipeline that we use internally for managing our cloud environments. What we're going to actually build is a small little web app running on Elastic Container Service in AWS. Right now, Carl, can you go to like the endpoint in the browser? Just want to show it's not running. And there it is, it's dead. You can see it, it's not running. What we're actually going to do is we're going to build this live. We're going to have the process fail first because like the rules that Josh showed, we're going to not meet one of them. And then we're going to basically remove that rule and have it succeed and talk about some other integrations. And really the theme here is that the OPA policy checking engine that Josh has talked about, we're going to show how it can be wired up into an infrastructure deployment pipeline, as well as some sort of addition things that we'll talk about. So, Carl, let's go to the repo and the look at the rules. So, can you kind of summarize these rules real quick? These are what we're going to be using to demonstrate.
Yeah. So for today's demo, so we're actually using the OPA binary, but we're using the Regula rules and libraries that they use to
write the rules in.
Yeah, execute the rules. So these are the 3 rules that we're going to be implementing. It's making sure that for EC2 instances that you only have sizes T2 small to T2 extra large, if you're familiar with EC2 instance types. We're going to be ensuring that all resources are tagged, and we're going to be ensuring that all the resources are deployed in the US East 1 region.
And like, thanks, Carl. And like what Josh said is, you can write any policy as long as it's checkable or able to be tested against your IAC script, or whether it's Terraform or Azure ARM or CloudFormation. You could write anything, very simple to complex. But Carl, let's dive into the tag one, because this is the one we're actually going to fail on. So let's open up the tag. Go back to the repo real quick.
Oh, sorry about that.
Yeah, that's okay. So let's open that up. And what this says, and you can see it's very sort of easy to read through. I'm not a developer, but it's saying that for these type of resource types, and you see there's a list there. Of course, all this is editable. You have to have at least 1 tag, and it has to be at least 6 characters. That's what this rule says. Tagging is especially for development, high turnover environments. Tagging we found to be very important for tracking orphan resources, making sure stuff doesn't live that we don't know about, that can lead to additional cost or to security threats. So yeah, let's jump into it. So so what we're actually going to show today is we're using AWS Code Pipeline, which is AWS's hosted CI environment. You could just as easily do this in Jenkins or Circle or Azure DevOps, or you could bash it all out. So we're going to use AWS Code Pipeline to run the demo. So Carl, let's jump into it. And this is yeah, let's dive. So before you click anything, these are the steps, and they're called code build projects. What's nice about Code Pipeline and Code Build is this is all ephemeral, meaning this only, the little containers that are used to do this work here, they only get fired up at runtime. So it's a very low cost, a few bucks a month, as opposed to having, running a server full-time, running Jenkins or something. So let's go ahead and hit release, Carl. And release here just means run, right? And what should happen once this fires up is our Terraform script, which is in GitHub, gets accessed. It gets converted to JSON and then passed to OPA. So as long as you can convert something to JSON, OPA can read it. It just has to be JSON. And then let's go to the tail of the step we're in. I think it's the OPA check step. Tail, this is just the sort of console output if you had a shell up. And what we'll eventually see here is that this is going to fail because it's going to include the tag requirement check, and it will fail because we have some resources as part of this demo app that don't have tags. So actually what it's doing live is, see, it's downloading the Terraform binary. We have to download Terraform at this step in order to output our plan event as JSON. And I think we failed. So yeah, so there in the red text at the bottom is the general fail message. And like Josh said, you can write the rigidness of your policy checks, whether they're sort of pass fail like we have here. You can do sort of an additive score. So maybe, you know, you have to hit a score of whatever amount you come up with to fail, or maybe you pass everything, but you give warnings to developers. But Carl, can you kind of summarize the output and show where we failed?
Yeah, so as we stated earlier, we're executing 3 rules, and 2 of them passed, as you can see in at the bottom in the summary, and 1 failed, and the one that failed is the tagged resources one. So if we go up here to the tag resources rule, we can see that most of them failed. We do have some resources that were tagged, but the vast majority failed. So the whole rule failed.
So now what we're going to do is we're going to open what's called a build spec file. This is basically a configuration script. This is where we point to the regular repo. I should say, let me pause here and make a statement. We built this pipeline before Regula came out, and we were using native OPA policies. What the Regula, and you don't have to use Regula to make this work, but where it provides a big advantage, really, in my opinion, is twofold. The Fugue has simplified, they sort of wrapped the OPA rules with some helper scripts that make writing the actual policies easier than writing sort of native Rego. And also what's been great, what they're doing is they are releasing rules that tie back to control sets like CIS or maybe NIST. So, you know, if you're in an environment where you maybe have to be NIST 853 compliant, this allows you to check things and tie them back to the work that was done to figure out, hey, this rule, this control, how do I actually write that as a policy? A lot of that's being done, and you know, we're going to contribute back to this. And as they release more, these libraries just become more robust and more feature filled. So let me pause here, and Carl, can you show where that rule was, and we're just going to comment it out.
Yeah, so I went through the liberty of already commenting out the old rule and uncommenting the rule that we're going to be using. So basically, this OPA eval is the command that you use to evaluate your Terraform JSON plan against certain either libraries or rules. And so we're using Regula's library, which supports the rule execution. And these 3 rules, as you can see in the old command, are pointed out right here. And then in the new command, we just are not using the tag resources rule.
Yeah, we just removed that. And what's nice about it is we can point to whole directories on the regular repo, or we can call out, as we do here, the individual file. So it's easy to add and remove the different rules. So okay, so let's go ahead and rerun the process with that rule removed. And what we hope to have happen, fingers crossed, is that it runs successfully. It'll build the infrastructure, it'll pass the rule, and then eventually we'll show you something that's running.
So to save a little bit of time, I'm just going to retry the step that actually failed, the OPA check. And as soon as it starts, we can go to the console output.
Yeah, it takes a few seconds for it to fire up because, again, this stuff is ephemeral. So, you know, the plus side is you could speed things up if we baked like Docker images that already had the binaries on them. The whole process takes about 5 minutes, so it's not too big of a deal. But what we really like is there's really no existing infrastructure, so we keep our costs down. And what we should see here in a moment is the final output of the OPA check, where it has parsed our Terraform script against the regular rules, the OPA rules that we're using, and it will pass. There you go. Awesome. And then, so what's happened now, if we go back to the page above that, is with this step done, it's now going to move on to the actual deployment step. So this is the Terraform apply, the verb apply, and Terraform world means it's actually running it and deploying it. So let's go ahead and look at that tail.
Hey, Dave, while
Yes, sir.
while the build is happening, just thank you for bringing up the fact that with Regula and OPA, you can use with Regula, you can use these OPA rules at the step we're showing you now, right? You can use them for checking your source code at the plan stage. But with Fugue, and Fugue has a free developer version that's free forever, you can actually use that same code. And Fugue, this is what we do for a living, is policy and security and compliance and all that stuff. Cloud security for engineers, for developers and engineers, by developers and engineers. That same policy that you're using to check your Terraform plan that we're showing you here can then be used to monitor the production environments. But it looks like we just got some progress. So I'll turn it back over to you.
Yeah, you're exactly right. So the way I think about it, and I have a graphic here in a sec, but actually let me talk to what's on the screen. So what's happening now, if you look at the line items, these are actual resources being deployed. So this is a full stack. It's got a VPC, it's got subnets and a load balancer. So we're doing all this live. And as Josh said, I've been working for a while, since long enough where I used to rack servers and run cable and patch panels. And he's right, it would take months. And now we're doing this. We're going to build this entire thing in a few moments because it's scripted. Again, that consolidates risk. Josh used the term sort of, there's less friction. I think about it like this. When I did this in the data center, we'd have probably 30 folks over a several month process look at design. Now, most of the clients we work with, there's 1 or 2, 3 core dev ops engineers. You've put all the risk on their shoulders. And to try and manage that manually just is not feasible. And that's why we believe this preventative policy checking combined with a as deployed checking is really important. And on that note, while this is running, it's going to take a few moments to build because it's got a load balancer. Let's go ahead and pull up, Carl, the graphic. I've got a little simple graphic that just illustrates can you kind of maximize that if possible? Okay, it's on the middle screen. So working left to right, what is going on is on the far left, we have source control. You can use any source, right? This is the GitHub icon, I think. We're using GitHub. It's very popular in this example, but it could be any source control. It could be a local file. The first step is with the OPA helmet. I think that's like a Viking helmet, maybe. We're parsing our source control document, our infrastructure as code document. It could be anything. It could be ARM template. It could be something like Ansible. It could be Terraform. It could be CloudFormation. It could be your AWS CDK that you've distilled down to CloudFormation. If you can JSON it, you can check it. We're proactively checking that against our rules. And what happens is on the Terraform step, as we saw, if it fails, if it doesn't pass, you can kill the process. You can just alert. You have lots of, but it's an upstream catch. The Terraform box in the middle, again, could be any IAC tool, but the key here is you have to commit to infrastructure as code in order to check it, right? It then deploys. We go into, and here we have AWS and Azure. Of course, if you're using Terraform, it literally supports anything I probably will ever touch in my career. GCP and Alibaba and OpenStack and hundreds of providers. Now, one of the things that's a little bit I want to call out here is now once we have our infrastructure deployed, as Josh said, and as probably everyone on the call knows, people are going to use the console, right? The UI. It's called Azure Portal. It's called the AWS Console. If they make changes out of band or out of this process, how do we check? And that's where we use Fugue. So Fugue monitors our environments, and it actively monitors them against a known baseline, right? So once we deploy, we say this is what this environment should look like. If someone went in and changed a port opening or made an S3 bucket public, Fugue tells us, and they can also self-correct that. So what we're going to show at the end of this is we're going to show how Fugue ties in, and this entire pipeline is automated. And that's one thing I want to stress here is this is all automated. So and the reason this is important is the Fugue piece, if we didn't coordinate with Fugue, what would happen is it would see our change as drift and potentially roll it back. So we have to basically stop our drift detection, do our deployment, and then tell our drift detector, Fugue here, that, hey, this is valid. So then it can then use that as the updated baseline. So let's go ahead and close this, Carl. And I think we should be getting close to being done. Okay, it's still running. So while this is running, we're near the end of it. It's creating a DNS record. Let's go ahead and pull up I just want to show the Fugue UI just to show what the old baseline was. So can you kind of point to the baseline?
So
Yeah, the time right there. Yeah. So
yeah, the time right
what this is saying is the last time this was run, and again, the baseline is the desired image, like sort of an image or a state of your environment, your AWS or Azure. It's saying the last time this was updated was yesterday around 2:12. And the reason I'm pointing that out is when this pipeline build is done, you're going to see this time updated. So let's jump back to the output, and we should be getting there. So
Yep.
okay, so
now Fugue is running and scanning.
so yeah, so what's happened now? And I just happen to know this because I know it's a sort of hard to read, but what's happened is all our infrastructure is built, and now we are instructing the Fugue API to update and create a new baseline. So while this is running, this takes about a minute. Let's go ahead and look and see if the app is up. See, it takes a few seconds for the DNS to propagate, but if we hit the thing, it might be ready. There it is. Okay. Okay, so now it works. So I know this is sort of the tip of the iceberg in that this is just a little simple screen, but under it is an ECS container, networks, and load balancers. So cool. So this real working stuff works. This happens to be some dummy data that we use for demos. And now if we go back to the output,
Still scanning.
it's scanning, yeah. Should be done pretty soon.
So like Dave was saying, this caters to the whole software development lifecycle, and if you want, you can put unit tests. You can implement unit tests in this pipeline. Some other software development checks that you would like. It's configurable to anything you want to do. Really, it's just a framework to get you started in terms of being specific for your organization.
Yeah, for example, we have a, oh, go ahead, Josh, sorry.
Thanks, Dave. One of the cool things about doing security this way with policy as code is in the past, and I'm mostly a developer, but I've definitely been through a lot of certifications and accreditations and audits. And I had friends who worked on that side of the house of the shop. And that old way of doing security, where you would build a whole thing and then people would go through it and audit it and look at every detail and then tell you where you're wrong at the end of the process, is really painful for everyone. And it kind of creates this gating function, like a toll booth you have to get through. But if your security teams can express policy as code, they're actually building useful tools for the engineers and developers to work in their normal workflow. And so you become a tool vendor, you become a bridge builder instead of a toll booth operator. So it has a lot of really cool side effects.
And one of the things I found, Josh, on that note is when you, especially committing to infrastructure as code, policy as code, they become artifacts in themselves. So they can be used as part of the proof, approving your compliance during those audits. So, well, the job ran, it succeeded. And as a final step, let's look at the the Fugue screen again, Carl, and refresh it. And what we should see if we recycle this is the time here for the baseline has been updated to a couple minutes ago, whenever this completed. Yeah, so a minute ago. And what this means now is that it rescanned, which captures the state of your environment. And we instructed it, again, this is all part of the code pipeline job. We're now using that latest scan as our quote baseline. So now what will happen is, if anything changes from that baseline until we instruct it to again, so let's say I logged in to do a demo and I created an EC2 by accident or opened a port, it will then capture that, it'll tell me about it, and if I've instructed, it'll actually roll it back. It'll programmatically remediate it, which is pretty powerful. So in summary, so this was the end of the demo. In summary, we showed a working pipeline. You can download we have all of this built as a CloudFormation template. It's a single file that you can deploy. It's part of everything we showed today is free and open source. And the Fugue side, there's a developer tier that's free. In closing, this is automating compliance and security in both a preventative way, which is where OPA fits in, and then we have Fugue on the backside as our parachute, ensuring that if something slips through, it gets caught and fixed. So Carl, thank you so much. I should say Carl has really done all the real heavy lifting on this, so I'm really lucky to be working with him. And Josh and team, thank you for inviting us. I'm going to pass it back over.
Dave, Carl, thank you. I love live demos, and I know they're always slightly stress-inducing, but excellent stuff. I'm going to just share again here, and we'll kind of close that out here.
Yep, we do have a few questions. If we don't,
before we
get
Q&A, let me just go through. I'm putting the links up now. We're going to have these out to you. But Fugue Developer free, AICF is the awesome work that New Light, Dave and Carl and their team have produced. Regula, Rego, and Open Policy Agent. These are all the things we're using. Every one of these things is free, and all but one are open source. The Fugue Developer is a SaaS product. So have some fun with it, and we'd love to hear from you. But sorry, Drew, you had questions.
Yeah, no, thanks for getting those up there. Yeah, so if we don't get to your question, we will reach out to you individually after the webinar with answers. So first up, I'll throw it to Dave, but everybody obviously feel free to chime in. Would Fugue work well with GetOps?
Well, that's a great question that I don't know how to answer. So I'm not. Yeah, go ahead, Josh.
Let me take that one because I'm a big fan of GetOps. Yes, absolutely. And I love that we got the question, actually, because I think GetOps is super cool. So if you're not familiar with GetOps, it's basically hooking Get to actual changes to the environment so that when you're doing things like commits and rollbacks, that actually just fires off the effectively CI/CD toolchain, but in a way that's very Git native. And I may not be expressing it perfectly, but that's the gist of it. Yes, Fugue is designed to work with any kind of automated toolchain and pipeline, including GetOps. And the way we do that, let me see if I can pull it up real quick. Do I have it? Let's pull up Postman. The way we do that is by putting an API on literally everything, just a simple Swagger API. And so if you noticed when they were, when New Light, Dave and Carl were showing us their really cool AICF using the AWS CI/CD pipeline, different things were happening via API call out to Fugue, like creating a new environment, running a scan. All that stuff can be handled through the Swagger API over here on the left, like getting a list of any environments. You can also, we added some features, and this is kind of cool. If you're getting into OPA and Rego, one thing you can do is if you use Fugue Developer, which is free, as I mentioned, you can just run it against your environment, you get a scan, and you can write OPA rules and then test them off of the last scan to see what those rules would return against your actual production infrastructure. So it's a little bit different way to get into OPA than with Regula, but it works really well. And I hope everyone goes and researches GetOps because it's cool stuff.
And Josh, I'm not sure if you said it, you may have, but when we built the pipeline we just showed, we're directly communicating with the Fugue API via curl functions and so curl calls. But you guys also have a CLI that simplifies some of that. So as long as you can hit either a URL or install a CLI, you can wire in any sort of, you can wire Fugue into any sort of automated process.
Yeah, thanks for that. So yeah, here we can do just a Fugue list environments. Any other questions, Drew?
Yeah, we got a couple that are similar. The one that just came in, I think, might encapsulate it the best. Does policy as code resonate better with newer or smaller teams versus traditional companies that have legacy systems? Is there a learning curve or educational effort needed for policy as code?
Dave, I'd love to hear you and Carl's thoughts on that since you've gone and implemented.
Yeah, I guess I'll start. I think it resonates better with newer. It depends how you look at it. I think it works well with both. With newer, smaller companies, you may not have the resources to manually check your infrastructure as code as thoroughly as you want to before you want to deploy it. And so, this creates an automated way that, saves time cycles for your smaller teams to, actually develop and do other things.
I think, yeah, I have a couple thoughts. I mean, smaller, more modern efforts are definitely easier to do, to leverage more of the newer technology, like we're talking about. I've worked with a bunch of big legacy environments, but one thing that I've been seeing, or at least pushing for, is as we demonstrate some of these different ways of doing business traditionally in the public cloud, is seeing how they can sort of backfeed to the data center. So, for example, if you have a big VMware environment and you are scripting that, you're using VMware's native IAC tool, like VMware Orchestrator, VRO, that can be JSON. And so you could apply this approach. You could apply OPA to your on-prem data center too. So I think in general, my answer is, big established environments, it's always harder to implement newer things, but I don't think that should stop you. So yeah, I'll stop there. Otherwise I'll repeat myself. Pass it back to Drew.
And the good news there is what we're seeing, it's really been interesting since we released Regula just a few weeks ago. The number of, like, I can't name any names, but major financial institutions and really large kind of traditional enterprises that are reaching out to us, to get demonstrations of Regula and how they can integrate it into their cloud efforts. So I think, the way that I think about that kind of question is, usually, whether it's a small team or within a large organization, there are the folks that are kind of leaning forward, right? And those are the ones who are doing this, but it is starting to happen across, startups, tech companies, and even names that would surprise you for their Fortune, 500 logos and long legacies.
Great. There's two different questions about automated remediation. Marissa asks, can policy as code integrate auto remediation as well, rather than a warning or action alert, i.e. remediating Terraform code at scan time with a warning to show the developer what was updated and why? And then another one was, we're using Lambdas for automated remediation, and can OPA work with this?
Okay, I'll field this one. I've seen a lot of people try this. So Fugue does automated remediation in a completely different way than things like Lambda scripts. We believe the right answer to this is to make the developers fix the infrastructure as code. And then once it is deployed, we do a kind of codeless auto remediation where there are no Lambdas to run at all. You just tell Fugue, enforce this, and it will automatically remediate any modifications to the environment once it has been baselined and approved. But the important thing here is, well, that's important, but another important thing is, if you're not getting your developers to fix the infrastructure as code, and you're relying on a process where the infrastructure as code runs, creates bad infrastructure, and then that gets modified in an automated way, a number of bad things happen. The first is, your infrastructure as code that is checked into Git is no longer accurate to what you've deployed in the environment. That's a bad thing. Your infrastructure as code, Dave was talking about using the IAC infrastructure as code and policy as code as artifacts. Well, if they're lying to you because you're doing things after the fact, they're no longer accurate artifacts. And also, people cannot read the infrastructure as code and understand what's in the environment. So that's one bad problem. The second bad problem is, you can really confuse Terraform by doing that. So depending on what change you make, it can happen such that the next time Terraform is run, it either creates infrastructure that you don't need or gets confused and fails. It's not a great approach in our view. So the way I would recommend doing this is by using things like policy as code to get the infrastructure as code correct, deploy the infrastructure as code, and then use, in Fugue, you would use what we call baseline enforcement, which is just, you don't have to write any Lambdas anymore. You hit a single API endpoint, and Fugue will just enforce the baseline no matter what changes.
And can I add one thought to that, Josh?
Oh, please. Yeah.
So I'm glad you answered that, because that was a better answer than I was going to give. But the technical, to what Marissa's asking, technically you absolutely could. And what what thought there is, because what Josh said is absolutely right, is if you're finding that your developers are routinely failing a policy check for a reason, rather than just that kind of arcane output on the screen, you can parse that output. So if it failed on that tag rule, you can have that failure, open up a clean template to say, hey, developer, here's an example of a good way to write your rule here. Or maybe here's a wiki that we've written on when you're writing security groups, here's what's valid and not valid. So in other words, you can automate the further education of whoever is deploying, so that they can then update or possibly use a snippet from something that's valid. So because this is all scripted, any follow-on action can be tied to this pipeline, whether it's linked to a website, automating another pipeline, or whatever makes sense given your business need.
Thank you, Dave. I totally agree with everything you just said. I certainly have my own view on it, but yes, if you wanted to do that, as Dave said, it definitely could work. I just showed here in this OPA rule where we're putting human readable, understandable response comments in here, and you could have just a link to your company wiki right there, or repo, or wherever you want to point that developer to tell them what they need to do.
And Josh, one final thought, it might be a repeat, but a customer I had a while ago, when we built templates in Visual Studio, and gave them, kind of like, here's a gold image network design, here's a gold image storage sort of spec, so that you gave them a boilerplate or template to start from that addressed most of that. So they would sort of have to actively undo something there in order to get that policy to fail.
Okay, great. We are at the top of the hour. Eric, John, Jen, we will get your answers, get you answers to your questions directly after later today. But thanks, everybody. We will also make available a video of this webinar. So stay tuned for that. And thank you so much for joining us. This was a ton of fun. Thanks, Dave. Thanks, Carl. Awesome work.
Hey, Drew, just real quick. I'm sorry. I'm gonna break ranks here and say, hey, Eric, the answer is yes. Policy as code can be used for serverless environments. We do it all day long at Fugue. Reach out to us. We've got a ton of policy as code for that use case. It works great.
Yes. Awesome. Thanks, Josh.
Thanks, everyone.
Thank you.